Okay, 11.1b, more simplifying radicals. Okay, so before we did on 11.1a, we did multiplying, but now we're going to divide. Okay, so a few examples, which we've already learned this part. If it's the square root of 16 over 25, that's the same as the square root of 16 over the square root of 25, which is 4 over 5. Okay, now let me get rid of these real quick. Okay, so a few more examples here. So if you had, what if they're not perfect squares though? So we have the square root of 11 over 49. Okay, well, that's going to be the square root of 11 over the square root of 49. Well, the square root 11 won't break down into anything, okay? It won't break down into anything that's prime. Nothing, because it's only 1 times 11, okay? So you can leave the square root 11 on the top, and the square root of 49 is 7. So this, you would leave your answer like this. This is your answer. It's okay to have that radical in the numerator. It's not okay in the denominator, which we'll get to in a minute. But it's okay in the numerator, okay? So what if we had the square root of 25 over b to the fourth? Okay, well then you do the square root of 25 over the square root of b to the fourth. Okay, so this would become 5, and b to the fourth, remember, is the same as the square root of b squared times the square root of b squared, which both of those are b's. So you would have 5 over b squared. Okay. Okay. Now, what if we have the square root of 25 over q squared? I'm sorry, 25p cubed over q squared. So again, it's going to be the square root of 25 times the square root of p cubed over the square root of q squared. Okay, this is the same as 5, and the square root of p cubed is the same as the square root of p squared times the square root of p. So this would become p times the square root of p. So we have 5p square roots of p over q. Okay, because remember the square root and the cubed, the square root and the squared cancel. Okay. So what about the square root of 75 over 16 t squared? Okay. Well, the square root of 75 can be written as the square root of 25 times the square root of 3. Okay, you want that because 75 is not a perfect square. Over the square root of 16 times the square root of t squared. Okay, so this is going to be 5 square roots of 3 over 4t. And you would leave it like that. Okay. Now what if we have the square root of 88 over 11? Now you can reduce this. Okay, the square root of 88 over 11 is the same as the square root of 8, because 88 divided by 11. So then you would do the square root of 4 times the square root of 2, which is what we learned last time. So it'd be 2 square roots of 2 would be your answer there. Okay. If it was the square root of 12a cubed over 27a, okay, now you can reduce this, okay, 3 goes into 12 4 times, and 3 goes into 27 9 times, and then we have 3 a's on the top and 1 on the bottom, so you can cancel that 1 on the bottom out and make this a squared. Okay, so you can reduce that. That's from chapters long ago. So then it becomes the square root of 4a squared over the square root of 9, which is 2a over 3. Okay, so you just have to keep working it step by step by step. Okay, so if you had the square root, let's say, of 40 over 5, you could go ahead and reduce that, because 5 goes into 48 times. I think we did one like this before. Okay, kind of like this. I just randomly picked this one, so it came out to 8 again. So then you know it'd be 2 square roots of 2 because we just did it up there. Okay, that's what happens when you make up problems as you go. Okay, so the last thing, and this can be kind of confusing. You cannot have no radicals in the denominator. You cannot have radicals in the denominator, okay? So if you have 2 square roots of 5, in order to get rid of it, you multiply it by whatever the denominator is. So you multiply by the square root of 5 over the square root of 5 because you're just multiplying it by 1 so it doesn't change the value any. Okay, the square root of 5 or square root of 5 equals 1, so you're not changing it. Now 2 times the square root of 5. Well, the square root of 5 times the square root of 5 is the square root of 25. So 2 square roots of 5 over 5 would be your answer. Okay? Now what if we had, let me go back to a different color, the square root of 3, I'm sorry, that's not what I meant to say. Whoops. 3 over the square root of 3. Okay? So we got to get rid of this radical in the bottom. So we multiply by the square root of 3 over the square root of 3. And we're left with 3 square roots of 3 over the square root of 9, which is 3 square roots of 3 over 3. Now we can cancel those. You cannot cancel it under the radical. So your answer would be square root of 3. Okay? Whoops. All right, so let's do a few more. So what if we have the square root of 7 over the square root of 8n? Okay, again, you cannot have this radical in the bottom. It doesn't matter what's on the top. Okay, in the denominator, you cannot have it, so you have to multiply by this whole thing. And again, this is just multiplying by 1, so it doesn't change the value. So square root of 7 times the square root of 8 is the square root. 8 times 7 is 56n over the square root of 64n squared. So the point is to get rid of the radical in the bottom. So if it doesn't get rid of the radical, then that doesn't help. Okay, so if we do the square root of 50, okay, so let's do the bottom. The square root of 64 is 8n. Okay, well, we have to see if 56, what times what equals 56? Well, 8 times 7, but what else? Is there anything that is, okay, so 56n, we have to figure out what times what equals 56. Well, we know this, you might not know this, but you can put in your calculator. The square root of 4 and the square root of 14, okay, will get us there. And it'd be 14n, or you could put the n with the 4, it doesn't matter. Okay, but the square root, but it's not a perfect square, so leave it with the 14. So this becomes, take that away, 2 square roots of 14n over 8n. Okay, now you cannot cross those n's out since this is over the radical. It's technically the square root of n. Okay, but we can reduce these to 1 square root of 14n, or you don't have to write that 1, over 4n. Okay, now there is an easier, not easier, but a quicker way to do this. Okay, you can do the square root of 7 over the square root of 8n. Okay, all you need to do is multiply this denominator to make it a perfect square. So technically we could have just multiplied by the square root of 2, but what you do on the top, on the bottom, you have to do on the top, because this would have given me 16n. You can do it that way and you wouldn't have to reduce at the end. So this would give me the square root of 14n over square root of 16n squared. So you'd be left with the square root of 14n over 4n. So it's the same answer. You just don't have to do as much at the end, but sometimes that gets confusing. Okay? Let me see if there's any more I want to do. Okay. So what about if we do 7m over 10. It's the square root of all this. Okay, so that's really the square root of 7m over the square root of 10, and we can't reduce these to perfect squares, so we have to multiply by 10, the square root of 10. Okay, now, yeah, we have to do that. Okay, so this becomes the square root of 70m over the square root of 100. Okay, so what would that be? 7 and 10. I don't know if that will reduce. Okay, so the square root of 70 will not, there's no perfect square that will go into the square root of 70, so you would just leave it as the square root of 70m over 10. And you would just leave it like that, and that is fine. Okay? And I think that's good. I think that's good on our examples.